Hi guys, this is Thomas from VicinitySoftware.com with a screencast on how to build push notifications for your doorbell using an Arduino. I hacked together this project a while ago and posted a demo of it on YouTube. What I didn't expect is many people to be interested. So I was a little surprised there. I got lots of requests to do a how-to on it. It took me a while, but finally, here it is. Before we get into it, I've posted the Arduino sketch and the Ruby script on GitHub. You can find the links in the post below. If you're watching this on YouTube, it might be better to head on over to my blog. I will post a link to this article in the show notes so you can find it easily. All right. So let's see. We're going to start off with the sketch. I did the project on an Arduino Uno. These days you can get something like Motino, which has a wireless integrated on it, which it could be better for this project as you're not bound to read out the serial port, and if you get a little creative, you might send an email or use a push notification service as I did. Um, you probably won't have nice APIs for it, but for a project like this, it should be simple to hack something together. All right, so the sketch. I started off with enabling a led pin for notifications. I also did configure the bell pin, which is the pin on which I hooked up the doorbell. As you can see in the previous video, I basically ripped apart an existing wireless doorbell configuration. These things usually go for 30 well, dollars, something like that, euros. You can also just look around if you can find them secondhand. I bought one for €2, I think, so it can be nice and cheap. It's somewhat of a hacky project, so what you find is that you often need to use a pull-up configuration. I'll post a drawing of what that is in the post. I suggest you read up on it because it's for these kinds of projects it's important to really understand what that is exactly if you want to hook something up to your Arduino. So let's get into it. Here we have our setup method, which is actually amazingly simple. We begin by setting up our baud rate for our serial, which in this case is 9600. I discovered later on that we can use the integrated pull-up resistor on the Mega. I didn't realize at the time that it had one, so I just implemented the circuit myself on like a standard breadboard, as you can see again in the previous video. Anyway, if you want to use that, which I suggest you do, it just makes it easier. You can just set the pin mode and then just submit input pull up. I'm using a pull up configuration here. I could have gone with a pull down, but pull up is more common. That's why the Mega also supplies support for it on the board itself. Okay, so the pin modes, the rest is pretty much self-explanatory. The LED pin is an output. Obviously, the bell pin is an input. This is the pin where we hook up our board. In this case, as I explained in a previous video, I just used the LED that's on the unit itself and hooked it up to the Arduino as someone hits the doorbell, the LED lights up, etc. It's an easy way to hook something up. All right, so we start with the LED pin on low, so everything is off. And then we come to the loop. I set an in-bell boolean, which I'll get to later. Um, it's basically for tracking when someone already rang the doorbell. I've added loads of comments to the code, so it should be easy to read through. So since we configured the bell pin to pull high, means the default status is high, and we're waiting for a low. A low will happen when someone hits or, well, rings your doorbell. So as the comment already says, we're using a pull-up resistor, so we're waiting for a low on the pin. As soon as that happens, we of course enter this if, and then it sort of depends on what sort of unit you got, but I find that most units, when you push the doorbell, the LED burns for quite some time. I mean, literally seconds on end. So we have to take that into account. Of course, we're looping, and we don't want every time that we pass the loop to send a message on serial. If we would do that, we would just, you know, get like 10 to 15 messages um, for one push of the doorbell. So we don't want that. So most radio doorbells switch for seconds on end to prevent another notification when we enter the loop again. We track within bell, so that's the boolean we created on top. If the board circuit is still low, so still low means the light is burning, it's on. I know it's a little bit counterintuitive, but you know, if you read the documents on what pull down and pull up resistors are, it'll become clear to you. The nice thing about this setup is also that when someone hits the button a couple of times, some people have this habit to just push 3 times or 2 times in a row. That you won't get like 2 or 3 push notifications. So it's a nice, you know, nice side effect. It's a perk. In any case, so we're checking if in-bell is false. So, you know, if it's true, obviously we don't want to print on serial. If it's indeed false, then we'll enter here. We switch in-bell to true, which prevents from triggering again in the next loop, as I just explained. And then we print just a simple one. We're keeping things really simple here on the serial. How we read this out, I'll get to when we come to the Ruby script, and I'll explain that in more detail. Just so we have a visual when we're testing, so that we have a visual confirmation of someone pushing that bell indeed, and that everything is working. I just used the LED on 13 to light that up when someone pushes the doorbell. So it's not strictly necessary here. All right, so well, it's logically we're looping through when, you know, the digital read on the bell pin is high, we'll enter the else statement, and you know, that, which is pretty much the default most of the time. Obviously, someone isn't ringing your door, so you'll end up here. However, there's one thing that's interesting here, and we should mention, is that when someone rang your doorbell and the cycle's finished and the pin goes high again, we want to check if we haven't if the in-bell is set, and if it was, we have to switch this back to false. You know, to just reset the state completely. Same goes for the pin here. We switch that to low again, so we'll switch the LED off. You know, this block of code only really triggers when the bell cycle has finished, for lack of a better word. Other than that, you know, you might not even need it if you have a unit that just, you know, gives a quick trigger. If you manage to implement it that way, that you know, it's just a quick high low. you might skip this completely. I wouldn't recommend it because you never know how long that pin will remain low. So you know it's good to have something that resets your state. All right, we're playing nice. At the end of every loop, we're waiting around for some time before we enter the loop again. We don't want to, you know, make the mega chip go nuts. Um, I don't care too much about this being a higher number because in this case I'm powering it off my USB since I have to have it on my USB in any case because that's also my serial port. So you might want to play around with different settings if you decide to use the wireless version of the Arduino. Um, but for this project, for this particular project, it's fine. As I said, the code is up on GitHub, so just feel free to download it, use it. It's got an open license, so you can do with it wherever you want. So on to the Ruby script. So how does this actually work? Okay, so we set up the Arduino to about of 9600, and you know, and we're printing a character on the Arduino serial. I think in my case that's COM3. So what we need to do is read out COM3 for any messages. Now there are multiple ways of doing this. You know, I by pure coincidence chose to use Ruby as I had it on hand. I developed this on my Mac. I realize I'm doing the screenshot on my Windows box, but it doesn't really matter. The names vary a bit, but you know there is enough information to be found on how to do these things. Okay, so I kept a nice and simple Ruby script here. You know, as I said, you can use Ruby or you can use something else. Just use whatever you want. I'll explain the Ruby script though. I'm using a gem called pushover, and serial port is I believe it's in Ruby itself. So there's no require for Ruby gems there. Pushover is a web service. I'll link to it in the post. It's nice and easy. You just set up a user with a token, and you can use their service to send push notifications. I'm sorry. Um, all right, so you know we start off with requiring Ruby gems because we need the pushover gem. We have, of course, a require on serial port since that's what we need to read messages from the Arduino. And this line is where I set up the serial port. On my Mac's case, that was just simply this. That is gonna be different for your use case. It won't be the same. So you just have to find out on which COM port your Arduino is broadcasting. In my case, it's COM3. That's very specific to Windows. You might be using Linux. You might be using OS X. Names differ, methods differ. This line is gonna look different for your case. So find out how to connect to the right serial port for your specific OS. All right, so we'll echo some information on the console here, so that we know the script is running, and then we'll just enter an infinite loop while true do something. All right, that is important because we want to keep listening here. So you do remember to keep things nice though. Don't forget the sleep. Whichever language you're using, use the sleep. You're gonna pull so much CPU time when you just when you skip the sleep, and it's not very nice, and you get like a laptop or a computer that's just using way too much power. All right, so here's the interesting thing. So every time we enter the loop, we're gonna just read a line from serial, and when we get a line back, because as you remember, we were only printing here a one, so we're keeping things really simple. So, and it's a print line, so we get a new line. So there we go, read line. Um, all right, so we got a new line with a one in it, and we're just echoing to the console. Hey, we got a bell there. We got a one. Um, so we can go on here. So we'll do a check if bell doesn't equal an empty string, because you never know what happens. There might be just an empty line being printed or whatever. We really want to be sure that someone pushed that doorbell and that the Arduino script did its work. If that's not the case, if it's not an empty string but it contains a one or whatever you printed here, um, we're gonna enter the pushover notification state. So the pushover API for Ruby happens to be very, very simple. So that's just a class method notification. We're calling it with a message, a title, which is, you see that instead of the phone number. So it's kind of nice to know it's immediately from your doorbell. Obviously, I removed my user key and user token here, but if you make an account, when you make an account at Pushover, you can find those in your settings and just paste them here. It's a free service until I don't know how many notifications, but I'm assuming that there's not that many people in front of your door that you will go over that boundary. All right, so this will send the notification to your phone. You'll get a message on your phone. Someone rang your doorbell, and that's it. Really, it's that simple. Um, it's a couple of lines of code. Again, the disadvantage of this method is that you do have to have your Arduino hooked up to your computer, because you're communicating to this script via serial. So I'm sure there's better methods like using the Modinho, I think it's called. I'll link to it, and it's you have a nice basis here. So if you were interested in extending this, it should be fairly easy. All right, that's it, guys. I hope you enjoyed it. I hope I managed to clear things up. I do realize I went a bit fast. I'm really assuming that you have some knowledge and you made already a couple of sketches with your Arduino. This is by no means a beginner's tutorial. If you have any questions, just comment. I'll try to clear things up. I'll do my best to help you guys out. Oh yeah, which would also be nice is if you get this running and you have a doorbell or whatever. It'd be great to just post a link down so that other people can refer to your project. As those doorbells, there are like a gazillion different types of these things. So your results will vary, and if we can collect it up a little bit, it would be nice. Since people are so interested, which again I was a bit surprised about. Anyway, that's it, guys. Thanks so much for being interested. It's really nice. Hopefully, till next project and a new screencast. Thank you very much.